Hey guys, we've got more discriminant fun here. In particular, we are looking at the harder, more problem-solving type questions. So, let's get cracking. Okay, so question 1. The discriminant of 7x squared minus bx equals 2 is 81. We want to find the possible values of b. So, remember the discriminant is b squared minus 4ac. Now we're told here that that is equal to 81. Now we know the value of a is 7, and if we subtract the 2, we would get c equals minus 2. Remember, a, b and c all have to be on the same side if we are in equation form. So, if we plonk our stuff in, we got b squared minus 4 times 7 times minus 2, we know that that is equal to 81. So we got b squared, well, minus 4 times 7 is minus 28, times minus 2 gives us gives us positive 56. So we got b squared plus 56 is equal to 81. If we subtract 56, b squared is equal to 25, and then finally if we square root, b is positive or negative 5. So that's why it asked us for the possible values of b, not the value of b. b can be positive or negative 5. Okay, question 2. Ax squared plus 4x plus 1/2 has a 1 real root. We want to find the value of a. So, in terms of the discriminant, what does it mean if an equation or a quadratic has 1 real root? Well, that means b squared minus 4ac is equal to 0. So, here we know the values of b. b is 4 and c is 1/2. So if we substitute our things in, we know b squared is 4 squared is 16. So 16 minus 4 times a times 1/2 is equal to 0. So 16, we got minus 4 times a times 1/2. Minus 4 times 1/2 is minus 2. So 16 minus 2a is equal to 0. Add to 2a, 16 is equal to 2a, and then divide by 2, 8 is equal to a, or a is equal to 8. Jobs are good. Okay, question 3. So this is when it starts getting really fun. We want to find the range of values for m such that x squared minus 12x plus 27 plus m has 2 real roots. So, good times. Let's first of all think about in terms of the discriminant what 2 real roots means. So 2 real roots means or implies that b squared minus 4ac is greater than 0. So that's why the question is saying the range of values, because we are playing with an inequality. So, let's see what else we know. A is 1, B is minus 12, and C is a two-term thing. It's this whole thing at the end that is not attached to an x. So C is 27 plus M, like that. So our discriminant then is going to be minus 12 squared. Let's write it all out nice and carefully. Minus 4 times 1 times 27 plus M. Now that is our discriminant. Now we know, because we have two real roots, that this has to be greater than 0. So don't lose the inequality as you're working through. Okay, alright then. 12 squared is, or minus 12 squared is 144. Then we got minus 4 times 1, which is just minus 4. So we got minus 4 lots of 27 plus M, like that. Now that is still greater than 0. Okay, if we expand the brackets now, we got 144 minus 4 times 27, what's that? 4 times 20 is 80, 4 times 7 is 28, so we got minus 108, and then minus 4M, and that is greater than 0. 144 minus 108 is 36. And then we can also add the 4M. So we get 36 is greater than 4M. So then we can divide both sides by 4. We get 9 is greater than M. So that's our answer. The range of values for M, such that the original equation has two real distinct roots. Has to be M is less than 9. Okay, question 4. Now I'm well aware this sort of question might look quite scary, but just take it one step at a time, work out what we know, and just go from there. Gentle steps. So, 2x squared plus 10n plus 1 lots of x plus 5 equals 0 has no real roots. We want to show that n lots of 5n plus 1 is less than 39 over 20. So, first of all, we have no real roots. So, what does no real roots imply about the discriminant? No real roots means that b squared minus 4ac is less than 0. So, there's our inequality. That's a good start. Now we need to plug in values that we know. So, off we go then. A is 2. B is 10 n plus 1. And C is 5. Okay, so now we're plugging these three things into our discriminant. So, we are going to get 10n plus 1 squared minus 4 times 2 times 5. get times. Now we know that is less than 0. Now if we expand these brackets, 10n plus 1 squared is 100 n squared plus 20n plus 1. Then we've got minus 4 times 2 times 5. Minus 4 times 2 is minus 8, times 5 is minus 40. Like that. So again, that's all less than 0. Okay, what can we do next? Well, we can simplify the plus 1 minus 40. So we got 10 n squared plus 100 n squared plus 20n. Now 1 minus 40 is minus 39. Now that's a good little sign, because we want a 39 in what we're trying to prove. Where is it? There it is. We want to get a 39 over 20 on the right hand side. So having a 39 now makes us very, very happy. So we can say 100 n squared plus 20n is less than 39 times. Now on the left, can we factorise it too? Yes, we can. Also good times. So we could first of all factor out an n. So we got n lots of 100n plus 20, like that. Now that is less than 39. We still have another common factor inside of the brackets of 20. So we can write this as 20n lots of 5n plus 1. That's good. We also wanted a 5n plus 1 inside of a bracket. So that is less than 39. And then finally, we can divide through by 20. So we get n lots of 5n plus 1 is less than 39 over 20, as we wanted to show. So we can work a cheeky little QED there at the end. We've shown what we wanted to show. Job's a good one. Okay, last question for this video then, so it's an old exam question. So, the equation k plus 3x squared plus 6x plus k equals 5 has two real distinct solutions for x. We want to show that k satisfies this lovely inequality down here. So, first of all, we need everything to be on the same side. So we're going to want to subtract that 5 from both sides. So we're going to have k plus 3x squared plus 6x plus k minus 5 is equal to 0. Now, we know that we've got two distinct real, right? So think about what that means in terms of the discriminant. That means b squared minus 4ac is greater than 0. Now we also know here then that a is k plus 3, b is 6, and c is k minus 5. So, if we plonk our stuff into the discriminant, we got p squared, which is 6 squared, so 36 minus 4 lots of a, which is k plus 3, times c, which is k minus 5, now we know that that is greater than 0, like that. So, before we expand these brackets up, I'm going to make life a little bit simpler. We can first of all divide everything through by 4. 36 has a factor of 4, and then the 4ac part has a factor of 4 too. So, if we divide through by 4, we get 9 minus k plus 3 times k minus 5 is greater than 0. Now, here, again, before I expand the brackets, let's just go back and have a look at the form we're trying to get into. We want our k squared, in fact, every k term, or in fact, every term, to be less than 0. So, what I'm going to do here, I'm just going to add the k plus 3 times k minus 5 to the other side. So, that's going to give me 9 is greater than k plus 3 times k minus 5, like that. Now, I'm going to leave the 9 where it is for now. So we're going to get 9 is greater than k squared. Now we're going to get minus 5k and 3k, so we're going to get minus 2k, and then 3 times minus 5 is minus 15, like that. So what we can now do is subtract the 9, so we get 0 is greater than k squared minus 2k minus 24, which is exactly the thing we were trying to show. Just go back up and check that. Yep, that's exactly what we were trying to show, except they've got it on opposite sides, so we can do that too. Oh, and I missed out my k squared. So we can say k squared minus 2k minus 24 is indeed less than 0. So that's the job done for part A. Okay, and then for part B we want to find the possible set of values that k could be. So, in other words, we are now solving this quadratic inequality. So to do that, we first will set it equal to 0. So we want to solve k squared minus 2k minus 24 is equal to 0. Remember, the reason that we do this is to find the points where the graph crosses the x-axis. Here, it's going to be a k-axis, but we're not worried about that. Okay, so we can factorise this. So, two numbers that multiply to minus 24 and add together to minus 2. Well, the minus 24 tells us one number is going to be negative, one is going to be positive, and the numbers are 6 and 4. Hopefully by the time you get here you're quite confident with doing this. So this tells us then k would be equal to positive 6, k would equal minus 4. So our graph It's going to be a happy quadratic because we have a positive k squared. So we know this is minus 4 here, this is positive 6. So our y-axis can go in there like that. Now remember what we want. Now in terms of the inequality, we want the range of values of x where the graph is under the x-axis or the k-axis here. So we want all of this stuff, but we don't want it touching the x-axis or the k-axis. So the range of values of k are minus 4, strictly less than k, strictly less than 6, like that. Okay guys, jobs again for this video. Up next, we're looking at more detail at sketching quadratics. Hope you found this useful. See you in the next video.